Okay, so this video covers the second half of section 5.4. We're going to pick up on page 203 as soon as we finish a quick bell ringer. So this I just want you to solve by factoring. So go ahead and give it a try if you're watching this video for the first time and see how you do. I'm going to work through it here in just a second to give you the answers. Okay, so for the first one, remember whenever we solve by factoring, we want to set up our equation so that we have the entire expression on the left side and then 0 on the right. So in this case, we don't have a quadratic trinomial, and we certainly are not looking at anything with like perfect squares. We've got 3 and 5, they're both prime. We don't have a constant, but what we can do in this case is we have a greatest common factor. So the greatest common factor in both of these is x. So I'm going to take out an x, factor out my x, and I end up with x times 3x minus 5, and that equals 0. So I have the monomial x. So when I set that up, x equals 0, I'm done. I've already got one value for x. And then for the second one, I have the binomial 3x minus 5 equals 0. And so then I just continue through until I have solved for x. 3x equals 5, divide both sides by 3, and I end up with x equals 5/3. So those are my two, solutions for x. Okay, so the second one, a little more complicated. No, so this one we do have a quadratic trinomial, but again, we have to move the constant term, the c term, over onto the left side. So I have 12x squared minus 22x minus 20 equals 0. Okay, so the way that I've done these is I look for the factors of the a term. Just as a reminder, this is ax squared plus bx plus c. And so my a term is a is the coefficient of the x squared. So in this case, that has a couple of different sets of factors. So I'm going to start with the easy one. 12x times x would give me 12x squared. Or we have 6x times 2x. That would give me 12x squared. Or I have 4x times 3x. And that would give me 12x squared. So my first term inside the binomials is going to be one of these three sets. So secondly, I have to look at the factors of negative 20. And so I'm not sure which one will be negative. So right now I just want to look at the factors. I have 20 times 1, I have 10 times 2, and I have 5 times 4. Now, for the most part, and we need some collection of factors where when multiplied together, when I multiply like the 12 and the 1, or the 6 and 2 times the 20 times 1, or the 10 times 2, I need to get this b term, the negative 22. So I always, for whatever reason, like to start with my middle term. So I know, so if I have 6x, let's see, and one of these has to be negative. So let's say I'm going to start with 6x minus 5. So I'm going to start with like these two factors. 6x minus 5 times 2x plus 4. Right, I know that negative 5 times positive 4 gives me negative 20. And I know that 6x times 2x gives me 12x squared. So all I'm going to look at here is I'm going to look at what the 6x times 4 gives me and what the negative 5 times 2 gives me. So in this case, 6x times 4, because these are going to add together to give me my middle term. 6x times 4 is a positive 24x. Negative 5 times 2 is negative 10x. And 24, excuse me. Okay, so I know that 24x minus 10x gives me a 14x. So that combination does not match the negative 22x. So let me try it another way. So what if I have, let's keep the colors the same here. Let's say I have 6x. Okay, so also the sign is wrong. So I'm actually going to flip both the sign and the numbers. I'm going to make this a negative 4 and then 2x plus 5. All right, so 6x times 5 is 30x. Can't be consistent. 30x. And then negative 4 times 2x is negative 8x. And so 30 minus 8, that gives me 22x. However, it gives me a positive 22x. So what I'm going to do is my last, because I'm getting closer, right? I've gotten the right number. It's just not the right sign. So I'm going to keep the 6x, except this is going to become a plus 4. So if the number is correct, then all the numbers, values are in the right place. No, just the numbers, right? But you need to flip your signs in order to make that negative. So I'm going to make the 4 a positive times 2x minus 5. When I do that, I get 6x times negative 5. So that's negative 30x. And then a positive 4 plus or times 2 gives me plus 8x. And that gives me my negative 22x. So this is the factored form of my original quadratic trinomial. Okay, so now that I've figured out the factored form, now I need to solve it. So we have, go back to dark, we have 6x plus 4 equals 0, and we have 2x minus 5 equals 0. And so I just solve 6x equals negative 4, divide by 6, x equals negative 2/3 once reduced to lowest terms. For this one, I'm going to add 5 to both sides. 2x equals 5, divide by 2, x equals 5 halves. And we're done. We have both of our answers. Okay, so that's the review of factoring. Let's go ahead and move back into solving by taking roots. So example 5 at the top of page 203 is the applied problem. So we have a problem where we have a phone. A cell phone has a screen that measures 3.5 inches diagonally. The aspect ratio is 3:2. Find the actual height and width of the screen. So this tells us that the aspect ratio, the 3 represents the height and the 2 represents the width. Because that's the order that it's given to us in. All right, so first we have to define our unknowns. Now, this means that height, the actual height, is 3 times x, which is the x will tell us what that variable is that gives us the actual height. And then width, the actual width is 2 times x. Now, the important thing to know here too is when we think about, so we've got a cell phone here, and they've told us that the screen measurement, so like when you have the screen, computer screen, TV screen, the width they're giving you, so it's like a 17-inch screen, that's the length of the diagonal. And what this does is, this gives you right triangles. And then the Pythagorean theorem applies to the hypotenuse of a right triangle. So if you have a right triangle, then the two sides, these are called the legs. That's your A and your B. Those are the two sides that connect to the right angle. And then the hypotenuse is your C. So the Pythagorean theorem tells us that the two legs squared and then those squares added together equals the hypotenuse squared. So it gives you a chance to calculate the length of your hypotenuse. And that's what we want here. So when we use this Pythagorean theorem, you can think of the height as your a squared, the width as your b squared, and the diagonal, so this is your a, this is your b, then the diagonal is your c. So, and that we know. So we have the height, so 3x, now be careful, the entire 3x is being squared, plus 2x squared equals 3.5 squared. So when we go ahead, I'm going to go ahead and simplify it, and then we're going to solve the quadratic equation by taking roots. All right, so 3x squared is 9x squared, plus 2x squared, that's 4x squared, and then 3.5 squared is 12.25. And then I'm going to combine my like terms here, and I get 13x squared equals 12.25. All right, so the 13 is not being squared. It's just the x. So both sides get divided by 13. And we end up with x squared equals, I'm going to go ahead and approximately 0.9423. All right, so now we have our quadratic equation. So solve it by taking roots. So this means that the square root of x squared equals the square root of 0 approximately. I should keep that. That's going to bug me. Approximately equals the square root of 0.9423. And in this case, we will go ahead and solve the square root using up to the 100th place. So I'm going to, so these cancel each other out, and we get x is approximately plus or minus 0.97. Excuse me. I think it's like 9.968 something. And so you just round it up. Okay, so now we want to find the height and the width using the positive value of x. Obviously, in this case, with most applied problems, you're only going to use the positive version of your solution, even though it is plus or minus, because we are talking about length, or we're talking about a distance. And that distance, think of it in absolute value terms. It's a measurable, obvious distance of, with a ratio of 3 to 2, 3 inches to 2 inches. So we can't have a negative size of a physical cell phone. So in order to find that, we have the height we know was 3 times x, so 0.97. So this gives us an approximate 2.9 inches is the actual height. Width is 2 times 0.97. And so we have approximate width of 1.9 inches. And we are done. That's what we're looking for. Okay. So now we're getting into the definition of an imaginary number. So whenever we solve previous examples we've always had some sort of x squared equals a positive number. However, if you have x squared plus 1 equals 0, but you need to create the quadratic equation with your squared value isolated on one side, so x squared equals, then when you do this, x squared plus 1, you move that 1, and you end up with x squared equals negative 1. Now, any number squared cannot equal a negative number. We've talked about this in class. So what this does is when you go to solve it, you take the square root of x squared and the square root of negative 1. Then these cancel out, and you end up with x equals the square root of negative, so x equals plus or minus the square root of negative 1. However, the square root of -1, you cannot have a square root of a negative number. It's not a real number and it's designated as imaginary. And so what we do is we use the variable I to represent the square root of -1 so that I equals the square root of -1. Now, this means that if you have I squared, then you have squared the square root of -1, and these cancel each other out, and you end up with -1. So I squared equals -1. Hold on. I feel like it's 1. No, it's not. Okay. So that's just something to consider. So I equals the square root of -1, which means that I squared equals a +1. That will get really important when we move on to the next section and talk about complex numbers. So that means for every squared I, you have a -1. Okay. We use this to take the negative out of the square roots of other negative numbers. So we always express other negative numbers in terms of I. So in doing this, we know that you can break a number down into its factors. I'm going to do this with baby steps here, but we know that this is -1 times 9. But then I know that 9 is a perfect square. So I'm going to go ahead and write 9 as, 3 squared, essentially. So we have the square root of -1 times 3 squared. I know that the square root of -1 equals I, and the square root of 3 squared, those cancel out and it becomes 3 plus or minus. So the square root of -9 is plus or minus 3i. Now this next example is just a number that's not a perfect square. We have 12. So this is just -1 times 12. The -1 becomes I. So this is the square root of, I also know that 12 is 2 squared times 3 is the prime factorization of 12, because it's 4 times 3, and 4 is a perfect square. So it's -1 times 2 squared times 3. So let me just break it down. This is like negative square root of -1 times the square root of 2 squared times the square root of 3. So I know that the square root of -1 is I. Give myself some room here. This is I times, this cancels each other out, so that becomes a 2. And then 3 is a prime number. It's not going anywhere. It stays inside the square root. So, and these are also plus and minus. So the square root of -12 is plus or minus 2i square root of 3. Those are all being multiplied together. 2 times I times square root of 3. All right, so let's look at an example of this. So taking roots with imaginary numbers. The first step that we take is we isolate the squared term. So in the case of this one, my squared term is z squared. And so in order to isolate it, I have to move that 45 over. So z squared equals -45. So now I have a squared number equaling a negative number. All right, so now we apply the square root property. The square root property tells us that we can take the square, just the same thing as like the multiplicative property or the additive property. To undo multiplication, you divide. To undo addition, you subtract. To undo squared, the exponent, you find the square root. So the square root of z squared times the square root of -45. These cancel out, and we know that we've got z equals. I'm going to break down 45. This is -1 times 45 is 9 times 5. Keeping the baby steps for now, I have the square root of -1. That's going to equal I. 9 is 3 squared, so that's going to equal 3. And 5 is just a little prime number. It's not a perfect square of anything. And so that just becomes the square root of 5. Just, I guess, to keep it looking the same. These are all plus or minus. So to put it all together in the correct order, we have 3i square root of 5. And we're done. That is as far as we can simplify it. All right, so let's look at another example. So for this one, we have a squared, instead of just a squared term, we have a squared expression. Everything inside this parentheses is being squared. So that means that we need to move everything around it to the other side of our equal sign. So isolate just the squared expression. So in order to do this, 2 times w plus 3 squared plus 10 equals 2 means that we're going to move, nope, getting ahead of myself here. I'm going to move that over, and we have 2 times w plus 3 squared equals -8. And now I divide both sides by 2, and I get w plus 3. The whole thing is squared, so the whole thing stays together, equals -4. All right, step 2 means that I apply, I feel like I went too far, took up too much room. I apply the square root property. Again, I'm just getting rid of the square term, -4. So this becomes w plus 3. And I know that the square root of -4 is the square root of -1, which is I, times the square root of 4, which is 2. So this is a plus or minus 2i. Now I still have to isolate the 3. So this is sort of step 3. I need to subtract 3 from both sides. However, the 2 is being multiplied times the I, which is the imaginary number. So we have w equals -3 plus or minus 2i, and we are done. We cannot, these are not like terms. Think of the I as a variable. Unlike pi, we cannot like turn it into its value and multiply everything together. So we would just keep this simplified. W equals -3 plus or minus 2 times this, 2 times I. Okay. I think that, yeah, that's it for the examples. The rest of this is going to be working through the homework that we did, which you already have. I got to figure out which ones those were. Hold on a second.